Okay, it's our pleasure to have Keyi Wang and Xiao-Yang Liu from Columbia University Secure Financial Lab to give a talk about financial reinforcement learning. Actually, yeah, I know Xiao-Yang actually for a long time over internet. So it's great to have this virtual talk. This talk is organized by the Central AI group and co-organized with Easy Encoder Academy, Toronto AI Practitioner Network, and Toronto Large Language Model Meetup groups. Yeah, without further ado, let's welcome Keyi and Xiao-Yang for the talk. Thank you.
Thanks for inviting us, Dr. Lee. So yeah, we know each other several years ago. Yeah, I have started to working on this financial version of reinforcement learning, starting from my master degree at Columbia and then PhD. And now we have this secure FinAI lab established last year. Yeah, so let's talk about this financial reinforcement learning. Let me see. Okay, today's talk will be split into two parts. According to our department of this FinRL, it essentially have two phases. So the first phase, I lead this phase. I trying to build this FinRL as a framework, and I will talk about the motivation, framework, and the key features. And then after that, I'm so lucky to have Keyi want to collaborate with me to pick up in the phase. So we organized a series of FinRL contests at different conference. So she will also present the overview, the trading tasks, and what is the current situation in our community. So a little bit about the background. Algorithm trading, which according to our statistics data, accounts for more than 60% of overall trading volumes in the U.S. equity market, and it needs to need the algorithm to make dynamic decisions, and we need to essentially decide where to trade, at what price, and what quantity. So trading in such a highly stochastic and complex financial market can be very challenging. And that's why we believe the deep reinforcement learning can help the quant trading. It can be a tech breakthrough that we really want to introduce this approach to finance. And it essentially solves the dynamic and sequential decision-making problem. It built a multi-factor model to trade automatically that can augment the human's capability. It can offers the very good feature of portfolio scalability and marketing model independence. So that's our motivation in order to design such a pipeline for a DIL-driven trading strategy. Essentially, we compare with the conventional machine learning approach and then contrast with RL's agents. So in traditional machine learning approaches, split this trading process into multiple stage. It involves the data processing and generate different signals. Can be alpha signal, risk signal, and then do portfolio optimization. So essentially, we need a model to manage the portfolio, and then have a very important component, which is called the execution part. After the execution, we do post-trade analysis. If it's like during the development, probably we do backtesting. Okay, but if we use the reinforcement learning agent, it essentially can take in the middle three part as like by taking care of using one agent. So in order to because different reinforcement learning have so many algorithms, and also in finance they have so many data sources, then we want to build a framework just like the TensorFlow and PyTorch. That why not we working on a financial version of reinforcement so that can automate the design of trading strategy for business finance people who are not good at coding. Then we have those principles in mind. The first is the full stack framework and allows customization. So the users can pick different algorithm, data, and different tasks. Then we need to emphasize the modularity and extensibility. And also reinforcement learning by machine learning is very important to make it reproducible. And in that by reproducibility means the researcher or the practitioner can convince his friends or his company right? If it's not reproducible, then there's a big issue of its credibility. And for our framework, we provide hands-on tutorial, like stepwise tutorial in Google Colab. Okay, so we build such an open source framework in financial reinforcement learning where users can have the following three features. Efficiency, we want to save time, computation with an automated pipeline from data to trading. And such approach have the scalability. Yeah, we want to also improve the stability and customization uh, capability of training, allow both customization and reproducibility. And with such hands-on tutorials and technical support, web documentation websites can be accessible to the general public. So here's an overview of this automated trading using FinRL. It essentially is split into two parts, just like the conventional reinforcement learning, but here we having trading agents and also market environments. So for the trading agents, you need to represent all those, they essentially represent the investor or the trader. And then the observation is trying to perceive the current state of the market. So that's the state. And then putting this state into the agent help taking action for trading, and then execute this action. It can be sell, hold, buy, or even long and short, and then get rewards from executing this action on the market, and learn from the past experience, trying to train a good strategy. Then another perspective from the market environments. So essentially, we want to represent the trading market. The state is the snapshot of current market conditions, or it can be encoding a past window into a latent representation of the market, and then receive the trading action and steps into the new state. So that's the basic definition of reinforcement, having the dream style environments have the step function and reward calculation, right? So in the right is just the overview. So the trading agent currently we support different reinforcement algorithms, and states is very important. The balance in the account, the shares for different stocks or crypto, and then different technical indicators. So here's the definition of our environments in the MDP language: state, action, rewards, environments. So we list all of them here. So the for the state we have the balance, shares, opening, high, low, close price, and trading volumes. So OH, LCV, and the fundamentals can extract two different technical indicators. We even connect with social network to get the sentiment scores, and also connect with the smart index that can extract from like uh, huge data, like alternative data to the market. And for actions, it can sell, hold, buy, sell, hold, short and long. It can also do portfolio allocation for different weights. And the rewards can be simply defined as change of the portfolio value or the portfolio log return, or even use the Sharpe ratio. And then for the environments, we connect with last Dow Jones 30, S&P 500, and Nasdaq 100, which means those constituent stocks, not only the index. So we also connect with different cryptocurrency, foreign, foreign exchange, and futures. But we didn't do that much in our code yet, although we collected it, but it's not very stable yet in this in the framework. And we also try to connect with the real time market data, support paper trading and even live trading. So here's the structure of this FinRL framework, essentially taking three layers. On the top, it have the application layer, which aims to provide hundreds of demonstrative trading tasks, serving as the stepstone for people to design their own trading strategy. And then in the middle, we have the agent layer. Essentially, it support fine-tuned algorithm for different deep reinforcement libraries, including the elegant IO that is library defined by developed by my group. And we essentially want to achieve the plug and play manner which we have played multiple times, and we hope it's it's friendly to be used. Yeah, and then on the bottom we have the environment layer. Aims to wrap up historic data or even live trading APIs of hundreds of markets into a training environment. And after talking about this framework, let's go through a homegrown example that I started in a workshop paper, New York 2018. So we at that time trying to cook up a demo that emphasized the practical approach of different for stock trading. And in this case, we still have this figure, so similar to the agent inaccuracy environments. So consider the scenario that we got $10,000 at the beginning of 2016. We want to invest those capital into the stock market. In this case, we pick the Dow Jones 30 constituent stocks. And then the trading frequency at that time, we're dealing with daily price. And in order to use new enforcement, we need to formulate the problem into the language of Markov decision process. The first question would be how to map the stock trading task into our language. And we need to essentially set up the state action rewards. Here, for the state, we pick the current market situation perceived by the agent, including the market, which is outside the agent. So it's like external environments. So we have the stock price and also process them into technical indicators. And inside this agent, you have the purse or the account, right? Money left in your account or the balance, right? And for this account, you hold different shares for different price for different stocks. And then action is what an agent can do. So here we set it to be very simple, just selling, buying, or holding. And then reward, it's incentive or feedback for the trading action, for the intermediate trading action. So here the reward is defined as the change of the portfolio value. The second question would be the agent trying to learn from the market environment, then how to design environments specifically for this stock trading task. Then essentially we want to incorporate real world stock trading constraint, including the market liquidity, non-negative balance, because we don't allow like short, and then taking care about the transaction cost, and if the user, right, it may be risk averse of market crash. So this stock trading environment, a little bit more about it. We essentially have 181 dimensions vectors that consist of seven parts. So the first part is the balance, it's just the real value, and adjust the close price because we're doing daily trading, only the close price of that day, and the shares for 30 stocks. So this have like a vector of 30. And then we have the different technical indicators. Here we have four of them. So essentially, one, one plus one, and then for the six of them, 6 times 30, we got 180, and plus one, then 181 dimensional vector. And then the action space is a set of all actions that the agent can act on those stocks. So for a single stock, we allow to sell. So negative means we want to sell it, K shares up to positive K, which means we buy K shares, and we set a maximum value like H max. So there are multiple stocks here. The size of the entire action space is 2K plus 1, and 30 to the power of 30. Okay, and then we need to normalize them into -1 to 1. Okay, which is a big space. And then reward function, we define it to be the change of the portfolio value. The agent will learn by getting the incentive for positive and negative change. The experiment that we did back then, we check and select the Dow Jones 30 stocks at the beginning of the January 1st, 2016. And then the training periods is from January 1st, 2009 to the end of the 2014. And then we pick a period for validation, which is also 1 year. And then testing is just less than more than 2 years, right? Okay, and then we download the OHLCV data from the Watson uh, research data service. It's a database, and then build the environment by setting those 30 stocks as the vectors of for daily stock price. So you just using this timeline and just pay attention to the uh, adjusted close price, and then validate this agent during this period, and then we combine those two two uh, periods together, and then we train the model, and then started to do the validate testing. So here we got the very simple figure here showing the performance. So for comparing with the GGI Dow Jones index, during these periods, it has a return of 54%, which is pretty high. And then we also compare with the mean variance method with a conventional method, lower than Dow Jones index. And then in this case, we get this DDBG algorithm work, which achieved a cumulative return of 96%. And then more of them, and like we calculate the annual return, standard deviation, and Sharpe ratio. So Sharpe ratio 1.78, 79, pretty high. But if you connect with real-time paper trading, maybe it's lower than this. Yeah, and then so essentially we're just getting one vulnerable demo to show that it's able to tune the deep learning software for a stock trading task. And then we provide several Jupyter notebooks then, and essentially three parts. There's one file to process the market data, wrap up into a market environments, and then another file for training the agents. So you have the training periods, right? And then the validation, and then the last part is the backtesting, including calculating the metrics in this table. Okay, then that's what I did playing with this FinRL framework. Next, Keyi will present her work of organizing a series of FinRL contexts. So should I stop sharing? So
Yeah.
okay.
Can you see my screen?
Mm.
Okay. Yeah, thank you.
I cannot see your screen.
Can you see now?
Not from my end.
I can see the FinRL contest. Yeah,
Okay,
from my
good.
side.
Yeah, thank you. Next, let me introduce our FinRL contest. This is a series of competitions to develop data-driven FinRL agents for stock and crypto trading. As FinRL develops, we hope its applications can be more practical and closer to real-world use cases. Therefore, we hold FinRL contests designing different tasks to attract participants to verify and develop innovative trading agents. And we also hope to support reproducible and systematic benchmarking of FinRL trading agents. These contests cover diverse tasks such as stock trading, crypto trading, large model engineered signals, and so on. So far, we have held 5 contests at different academic conferences. 3 of them have concluded successfully, and notably, we have 120 participants who formed 85 teams in the held at IEEE IDS 2025. And the one at IEEE CS Cloud 2025 is currently in the evaluation phase, and we have also just started the contest at the ICM ICAVE 2025. With more and more contests, they are forming a community-driven effort to promote reproducibility, transparency, and benchmarking in FinRL. We have been actively maintaining this FinRL community through these competitions. The FinRL contest have attracted over 200 participants from over 100 institutions across over 20 countries. This is the geographical distribution of participants by country. Most of them are from Asia, North America, and Europe, and 70.5%, 3% come from academic institutions. 19.1% are individuals, and 10.6% come from industry. The FinRL community continues to attract students, researchers, and practitioners who actively discuss and contribute on different platforms, including GitHub with over 15,000 stars, and Discord with over 550 members, WeChat group with 600 members, and Google Groups with over 450 members. And in the following session, I will mainly discuss our contest tasks and how we maintain this community. So based on our FinRL project and also feedback from the community, we select several stable and representative trading tasks for the FinRL contests. We categorize them into two groups, stock trading and crypto trading. And the workflow of the trading tasks is shown here. Firstly, in the data engineering phase, historical or real-time market data and alternative data are collected, cleaned, and pre-processed. Trading signals or alpha signals can be extracted from this data through feature engineering or factor mining, and large model engineered signals can be extracted by processing unstructured data using large models. And the data and features can then be processed into market environments. And secondly, in the model training phase, FinRL agents interact with the market environment to learn trading strategies. Thirdly, in the model testing phase, the trained agent is tested on unseen data, typically through backtesting or paper trading, and feedback from the post-trade analysis can help improve the previous stage. This is the workflow that participants need to work on to develop their trading agents. Now, let's look into the tasks. This table summarizes the stage, action, and reward of stock trading and crypto trading tasks in our contests. As we can see, the very first task is just a simple stock trading task. The stage includes balance, shares, and we use the OHLCV data. And also we include technical indicators. The action is buy, sell, and hold, and the rewards is the change of portfolio value, just like the demo we showed before. And in the subsequent contests, we use more data, such as limit order book, sentiment data, social data, and so on. And we also focus more on crypto trading, which is more challenging, but closer to real deployment. And for stock trading tasks, in our first contest, the first task is to train a stock trading agent by applying data and feature engineering. This task is adopted from the previous demo showed by Yanglet and has been clearly defined and well studied in FinRL. This task mainly addresses the challenge of dynamic market data. We know that financial markets is non-stationary and dynamic. The market conditions always change. And we encourage participants to employ innovative and effective data and feature engineering strategies. In the next contest, we focus on the large models. We hope to develop large models that can generate trading signals from financial news by using reinforcement learning from market feedback. We know that general purpose large models they are trained on internet data and cannot capture the intrinsic dynamics of financial markets. This challenge is the motivation of this task. To align large models with financial markets, we encourage adapting large models using reinforcement learning from market feedback, which is a counterpart to reinforcement learning from human feedback. So in RLMF, we utilize the feedback from the financial markets as the reward signal. And in this way, large model can learn from financial market behaviors. And in 2025, this year's contest, we approach the large model engineered signals in a different way. So it is to develop stock trading agents by combining FinRL and large model engineered signals. Unstructured financial texts like news, SEC filings, they contain valuable information about market sentiment, risk, and events. Large models can extract signals from financial documents. These signals can be integrated into FinRL. So this task was selected because it reflects real-world decision-making, where financial analysis and traders, they rely on both structured market data and unstructured financial text. And here we show how to get large model engineered signals. Time series data, financial news, and SEC filings can be collected from different sources, and large models can analyze these multimodal inputs to generate signals such as sentiment signal, sentiment score, or risk level. For example, we ask a chatbot to generate a sentiment score of 1 to 5 about a piece of financial news, where 5 means highly positive and 1 means highly negative. And after getting this sentiment score, we can add it as a feature in the state of the market environment, or we can use it as a scalar to adjust our action. Then let's take a look at crypto trading task. Different from stock markets, crypto trading faces greater volatility due to large price fluctuations and market sentiment shifts. It's more challenging to develop robust and profitable trading strategies. Our first crypto trading task is to train a crypto trading agent for Bitcoin by using ensemble methods. And we use limit order book data in seconds. RL policies are unstable. Its performance is very sensitive to hyperparameters and market noise. And ensemble methods have shown effectiveness in mitigating policy instability. This task extends this idea into crypto trading task. In addition, collecting high-quality data sample is often expensive and limited. To overcome the sampling bottleneck, especially during training multiple agents for an ensemble, we employ massive parallel environments. And the next task, FinRL AlphaSeq, extends the previous task by introducing an additional focus on factor mining. Factors play a critical role in driving trading decisions, and this task is to develop a two-stage pipeline. In the first stage, we perform factor engineering and selection, and in the second stage, we use ensemble learning to build robust trading agents. It aligns with the industry need for effective alpha and beta signal extraction in crypto markets. And then this year, our crypto trading task, FinRL DeepSeek, extends the previous two tasks by introducing another focus on large model engineered signals. Crypto markets are highly sensitive to news headlines, tweets, and viral narratives. The timely interpretation of market sentiment is very important. So in this task, we encourage participants to explore large model engineered signals for trading Bitcoin and integrate them into FinRL. And in our new contest, the new crypto task is to use transformer-based architecture as policy in order to overcome the challenge of limited temporal memory and policy instability. So we will look into some technical features I talked before here. The first one is the ensemble. One of the key challenges in RL is policy instability. The performance of RL policies can be highly sensitive to hyperparameters, unstable environments, and even random seeds. The agent will have unstable performance. So to address this challenge, we leverage ensemble learning, which combines the predictions of multiple models to improve the overall performance. In the context of FinRL, we use multiple RL agents like PPO, SAC, DDPG, which are trained on different environments, and the ensemble approach aggregates their decisions using weighted averaging. We also utilize massively parallel simulation. Another biggest challenge in RL is sampling efficiency. Financial markets are highly non-stationary and dynamic. Market conditions change unpredictably, so it requires extensive sampling to train our agents. To address this challenge, FinRL utilizes vectorized environments. So it allows to run multiple sub-environments in parallel. So each sub-environment simulates its own market scenarios, including balances, prices, holding shares, and so on. And in this way, we can simulate trading on thousands of environments in parallel. It can enhance resource utilization and also improve the sampling speed. The third one is FinRL using decision transformer. Traditional FinRL policy architectures like MLPs often struggle to generalize due to their limited temporal memory and policy instability. Transformers with their attention mechanism can learn complex temporal patterns and long-term dependencies, especially in time series data. So in the traditional setting, we mainly get current state from the environment, and the policy will output the action. This process will repeat to get trajectory samples, and the policy is optimized based on the trajectories. Differently, decision transformers formulate offline policy learning as a sequence modeling task. So after we collect high-quality trajectories, we embed them into return to goal token, state token, and action token. And then the transformer will predict the action autoregressively. This is about our tasks and some technical features. Next, I want to discuss how we develop and maintain our community. Here we show the contest process. So firstly, participants will register their team through Google Forms. In this way, we can maintain a growing mailing list of over 300 participants, which is also continuous growing. And next, participants can learn FinRL and FinRL contests through our tutorials. Here, I provide more details about our tutorials. We provide task-oriented demos. We also actively maintain a documentation of all tasks, talking about why we set up this task, what the data looks like, how we process the data sets, how is the performance, and so on. It provides much more details. And we also have a blog to introduce FinRL for the beginners. So back to here, after learning tutorials, the third step, we provide starter kits, including data baseline solution code and detailed instructions. Participants can learn starter kit and develop their own trading agents. They communicate questions through Discord and email. And we also strongly encourage them to create GitHub issues about technical questions, which is a standard way in the open source community. And then after that, participants submit code and papers in the standard format. In this way, we can improve the quality and the reproducibility of academic research. And for the submitted papers, we invite experts to review and provide constructive comments, and participants can revise their paper based on this advice and submit the final version. Through this process, they can improve their academic writing and learn scholarly communication. And also, during the same time, we evaluate models on testing data. And finally, we conduct the award ceremony and the academic conferences. Here we show the contest winners. We issue official certificates recognized by the organizing academic conferences and Columbia University. Participants can also publish a short paper in the conference proceedings. For example, in IEEE IDS 2025, there were 11 papers accepted and finally published. And in IEEE CS Cloud 2025, we have accepted 15 papers. And here we show the structure of our community. So our core team consists of 5 to 10 organizers. There will be one core leader to design tasks, manage the logistics, and coordinate all tasks. And each task has a task leader with 1 to 2 students members responsible for developing starter kits, addressing technical questions, and evaluating submitted models. And some former participants joined our organization team later. And our contest participants are contributing developers. They create their solutions based on the starter kits. Up to now, we have over 230 participants. Many participants rejoined the contest for new tasks. Several participants later also joined the core team to help organize subsequent contests. And then the bug reporters are members of the broader FinRL community. The FinRL-related projects on GitHub now have over 15,000 stars, over 1,000 issues, and over 800 pull requests. The users learn FinRL through contests and our tutorials and apply related projects for personal or industry use. The application of FinRL in crypto trading has received strong interest. Yeah, that's all for my part. And if you are interested in our upcoming contest, you can scan this QR code to visit our website. Thank you.
Yeah, thanks a lot for Xiao-Yang and Keyi for the wonderful talk. Yeah, other questions from the audience? Let's see. You're welcome to just, open your mic or type in the chat. feel free. Yeah, I think this works is pretty good, especially from the academic part. But probably it's also very practical. If there are no other questions, let me ask this. Probably many people are interested in this question. Since you are also in New York, so how about referral learning on Wall Street? How's that, used by those companies, like say Bridgewater, Renaissance, or even say JP Morgan? Yeah, I know the professor, uh, I cannot remember the name exactly, he was in CMU and he's now in JP Morgan, right? So, yeah, how do you know some insider information on Wall Street? How is referral learning used there?
Keyi, would you like to share some of them? Is in particular from those participant teams. So Keyi, do you have such information because of those registration teams, some of them from the industry?
Yeah, I know that, for example, one participant is from the industry, but she personally is very interested in financial learning, and she just developed joined this contest and developed her own trading agents. Use these trading agents to develop, to actually transit from traditional finance industry into the quantitative trading industry. I know that this is her goal to participate in this contest.
Okay, from my end, I do interact with over 5 companies. Many of them are the startup. So they actually showcase their trading agent, even record a video so that I can help them trying to uh, connect with companies they want collaborations. Yeah, and another thing that we are encounter currently is like is because it's about trading strategy. So the industry participation is not very high at this moment. That's why recently we started working on the zero knowledge proof as a technology, so that the participant team do not need to submit their model to us or do not need to uh, release the model open source. Essentially, they just release the testing logs that was processed by using some hashing function. And then we introduced some zero knowledge proof in order to verify that, okay, that kind of like trading curve is actually generated by this claimed model, which we have no access to the model's structure or the model weights. So we want to introduce this zero knowledge proof into the current competition so that we help the industry companies can participate and also our participant teams can talk about the strategy in a high level and attract the industry people to sign contracts with those teams.
It's
Yeah.
just a follow up. You mentioned the JKP. I heard that JKP is not very efficient. How is your experience in finance?
Oh yeah, it's not efficient. So that's why my team is working on high performance computing. Those packages implemented in CUDA, and then we need to do optimization on them.
Okay, yeah, that's yeah. Hopefully
Yeah,
you
that's
can find some very efficient algorithm. But probably that's an open problem, right? I guess.
yeah, yeah,
Okay.
yeah.
Yeah, there's a question from the audience. Let me
Thank you
introduce.
for the
Regarding portfolio optimization, I'm curious if I can set constraint for certain tickers, such as a tolerance window when using FinIR.
mm,
Uh,
tolerance window.
constraint for certain tickers.
Yeah, but what is a
Tolerance.
tolerance window? Maybe I guess you will see, okay, for each stock that you have allowed or acceptable action, maybe, right? So for that one, essentially you just need to uh add a condition in the action, and then it can either in the training part or in the execution part. According to my previous experience, I don't need to, it won't cause big trouble. I was just using if-else conditions to check those constraints.
Okay, yeah. Thank you. Let me see. Yes, as you mentioned, simulation, I think that's also important. And there's also, lots of people are talking about world model.
What
So for reinforcement learning, the world model is basically transition model and reward model. You mentioned the simulation, but I'm not quite sure whether yeah, how does transition model and the yeah, reward model you can define, but how about the transition model? How to define that? Yeah, or even how to estimate it. I think that's probably yeah, how do we do that? What's your
Oh, I didn't
understanding?
get to the later part because I heard about the water
Oh,
model part. Then
I mean,
why we are
basically, how do you, yeah, I think you have some definition for the reward model. I read the paper briefly, but for the transition model part, I'm not quite sure. Transition, from this state to next state. Yeah, how do you do that transition model? Yeah.
transition model,
For the learning, we need
traditional model or transition model,
transition.
tradition model,
Transition,
traditional
from
machine learning model or
state action
traditional
to next
model
state.
for markets.
Yeah, state
Uh,
action to next state, right?
yeah, which are you asking? Traditional machine learning model or traditional model for the markets?
Oh yeah. Sorry. Yeah, I mean transition. From state,
Yeah,
either state
transition.
take action and going to next state. Yeah.
Oh, okay. Yeah. So this is a very important part of building market environment, even training the reinforcement agent. It's very important to build a very realistic transition model. Yeah, it's very important. So at the beginning, when I started working on this field, I just used the historical data. Then essentially just checking the market price and assuming that the execution of the action won't make a big market change. So essentially, is just essentially we assume that our action won't have a big impact on the market at all. Okay, and now if you want to do a more accurate model of the market transition, right? You can take we kind of taking care of the limit order book, so you need to check in the tickers different tick right different time and then the submitted orders. Yeah, and then for that part, it needs more modeling of it. Actually, I know that this year the New York they accepted a paper of using reinforcement to do the market volatility prediction. Essentially, they are play with the limit order book data and then trying to say,
Okay.
okay, this is a queue. Order queue, and it's essentially a stochastic process, right? And then how to use reinforcement to do that. Yeah, and there's a paper that maybe put online soon. I think it should get accepted.
Okay. Yeah. I can check with you. Yeah. But
Okay.
I'm thinking if you just from historical data,
Yeah,
they may not cover all the cases.
yeah.
Since we want to have basically
Yeah.
a world model or so
Mm.
we need to have a transition model and real model, and then we need to the model need to cover uh some cases unseen in the historical data. So yeah, how to deal with, for example, if you take this actions, this strategy, and you may go into some state not in the historical data. So how to deal with those cases?
I think there's another team from Berkeley that writing the very good paper of a survey of reinforcement in finance. That team they really believe in it's very important to use synthetic data. Because, right, in the market, it's just one time thing. You only see it once. But essentially, the market can be different, have randomness. So they propose that it's very important to use synthetic data. You can use either again or recently they are working on with diffusion models. So we believe such market generation or simulation can be very important to train a robust trading agent. Although my team also started working on that, even a water model. Yeah, but this may
Yeah.
be a
Yeah, now that
too
people call it world
long.
model, but basically, transition and reward, right? Basically.
Yeah, essentially
Yeah.
that.
And
Yeah.
there's a question from the audience. how
Yeah, how
does
does
multi-agent
multi-agent?
DDPG compare
Mhm.
to PPO? Yeah, it's a general question, but probably your experience in finance. How do you compare
Yeah,
those?
yeah, I think I'm not the big expert here. I got a friend from Yale who working on the multi-agent deep reinforcement, even write a very good survey on that. In my team, I actually play with the multi-agent DDBG in order to do the order execution, but it's just a small paper. Based on my own limited experience, I would say I still prefer PPO because if you call it like multi-agent DDBG, then I want to see that okay, if it's two agents, what is essentially trained or shared? Are they sharing the same state space or latent state space? Are they reducing the action space? We don't have a reason why multiple agents DDBG is better. So actually this MDTPG is included in our library, but I'm not convinced. So in my own playing, I was using PPO a lot. Especially recently they have the GRPO advanced version here. So I prefer PPO. I vote for it.
Okay, yeah, let me. Yeah, um, yeah, I think you also. I think that's a probably interesting or even important question. For evaluation. Yeah, I think for research papers for competitions.
Mm.
Um, I think most evaluations now are, for example, point estimation based on, for example, mean or median, those kind of things. And there was the nearest 2021 paper. They are talking about other, statistical measures for evaluation. Yeah. So what's your thinking or experience? For finance, should they have some interesting performance measures to
Okay.
evaluate algorithms.
Okay,
Yeah,
you mean reinforcement algorithms, right?
yeah, especially
Okay.
algorithm in finance. Do we need some unique performance measure? Rather than just mean or variance.
Okay.
Those stuff. Yeah.
Thanks for this question. Yeah, I think evaluation very important. Maybe Keyi, would you like to take in a perspective from the participant and evaluation organizers' perspective to share your opinion, right? Because you probably encounter each time over 30 or 80 submissions. Now, how do you deal with evaluating them? There's no single criteria working in the market, right?
Oh, do you mean the performance metrics?
Yeah, performance metrics because you cannot
Uh,
rely on one metric, right? Because
yeah.
people, right? How do
Actually,
you, yeah.
Actually, for FinRL contest, we adopt multiple metrics in terms of financial trading. For example, we use the cumulative return. This metric can reflect the profitability of the trading strategy. And then we use the Sharpe ratio. Sharpe ratio can balance the profitability and also the risk. And then we use the maximum
That's well done.
drawdown,
Mm.
and then it can reflect how the trading strategy performs like in a with a downside risk. So basically, we adopt the widely used metrics in financial industry to measure the performance of FinRL agents in both profitability and risk. These perspectives, yeah.
So from my understanding, you think that it's very important to taking care of two aspects, the profitability and also the risk, right? So the return, the Sharpe ratio trying to balance two, and then the max drawdown trying to see how fluctuation in those trading strategies. Okay, I agree with that.
Yeah, yeah, that's great. Thank you. Yeah. Um, Let me see. Yeah, yeah, you mentioned the descendant transformer. Transformer, yeah, now is the dominant neural network
Yeah.
format for many things, language model, many things. But for finance, sequence time series data, I wonder if other networks, for example, long shot uh, time like RSTM, maybe better or not. Are you say comparing this, or are there some people working on this? And this year there's a new new form of LSTM.
Yeah, yeah,
Other
LSTM, right?
people, trying to compare those
Yeah,
uh, different different new
mhm.
network architecture. So
Yeah, yeah, yeah. So, Keyi, could you like switch to the page of the decision transformer here? Right. Yeah, at the beginning we were using simple policy networks. So we started to develop this FinRL and elegant IO. Then later on, when we play with those financial data, actually a lot of like community users complain saying that okay, you're just taking one snapshot of the market. Maybe you should encode a window into that Latin representation of the market. At that time, we were trying to start play with LSTM, but not very success. But recently, we because of my other research we do see a lot of advantage of play with transformer, which have a much longer, can deal with much longer sequence. So which means the memory size is much bigger than previous RNN network. Yeah, that's why we picked the decision transformer here, just trying to introduce a stronger network with larger memory. But today or yesterday, I saw the new version of LSTM is called XLSTM, and we haven't started working on that. I think our students at Columbia, I have so many students in my team, so we encourage students to play them and trying to share the experience. If we got like if we get some positive results, we'll be very happy to still open source them and then put back to the FinRL framework or in future FinRL contexts.
yeah, yeah, thank you. Yeah, yeah. Before the talk, we have a little brief discussion. You mentioned, like paper trading. Yeah, trading with the real market is risky, right? And
Yeah.
so, how's that going? Are there some good tools, techniques, or something for people to, try different strategies? Uh, yeah, yeah. Are there
Yeah, yeah.
something?
Great, great. I do interact with nearly 10 prestigious companies in Wall Street, and a lot of the senior managers tell me that it's very important to to do very serious principle testing or paper trading so that trying to prevent any leakage of future information. So paper trading with clean professional setting is very important to convince them. And another is like if you actually use, for example, 20K in your account and have a real trading, in that case, it will be more realistic because if you are dealing with the real trading, then you have to take care about the slippage and whether your order actually executed or not. Because if you do paper trading, you just assume that whatever action you want to take, the order will execute successfully. But if you do with real world trading, maybe there's slippage, maybe your order is rejected. Yeah, so they suggest me to continue with paper trading and also real trading. So in our FinAI context, we are starting to introduce the paper trading in several of them, at least 3 times now. And then inside my team, actually, a lot of students get very excited about trading, apply this FinIO into real world trading. Although each time I tell them they need to be careful. I don't take I don't take responsibility for whatever they fail in the markets, right? But students are very excited to play on their own. Yeah. In that case, we have a lot of discussion, internal discussion, slippage, very important. Failure of execution your order may fail. It's also another factor you need to take care of.
Okay, yeah, that's great. Yeah, maybe. Although just now we discussed that, but let me ask that question again to share with other people. So why do you choose the secure AI, secure financial AI life? Why do you yeah, I have highlight secure here?
Yeah, 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 yeah. My journey was applying AI to financial applications is because I started to my master degree at Columbia, and from master to PhD, I got like 60 credits, which is about 20 courses. That's too many, and I really got sick of it. So at the beginning, I was thinking that okay, I have to do so many courses, and it's graduate schools, and how about I delegate all those course into a major theme? So naturally, I think about applying AI to finance, which is underexplored field back then. And then also like JP Morgan have a new director in the AI research team, Tucker Borch, who left last year because after his 6 years of term. And but I'm lucky that they also started to explore this journey back then. So when I started to working on this presented paper of New York 2018, uh, JP Morgan also started to organize a workshop at the NURBS, and that's the first time we met at the NURBS Vancouver. Yeah, 2018, December. Okay. And then after playing with AI into finance, we do get attention in the open source community, a little bit about the AI community, and a lot of company interact with us. And I feel that it's very difficult to convince them because the finance field is more conservative. They have all those regulation department that saying, okay, if your strategy you are using deep neural network is black box and you don't have interpretability, so whom to blame, right? What if like how to do risk control? And they have a lot of concern with proprietary data. Yeah, even in our previous context, we're trying to reach with data vendors, several of them, and they all reject to provide us high quality data because by law, by policy, they just cannot. Yeah, so privacy, privacy of the data, privacy of the business security inside the company, privacy of the trading strategy, privacy of your trained model. Yeah, so that's we find it's difficult to convince them. So our lab started to adopt different security and different data privacy method like federated learning, differential privacy, and zero knowledge proof. Yeah, so this year I have a paper accepted at the New York workshop about zero knowledge proof. So because of those scenarios, we find that we have to get a mechanism so that we can release our result without showing the model weights itself in order to convince the reader or uh, improve the credibility of our research. Otherwise, people will see, okay, if your model can make profits, why you open source them? Yeah, so we want a mechanism to talk about these methods and don't share too much and attract the external company to sign contracts with the developer team.
Yeah, that's wonderful, wonderful talk, wonderful, yeah, answer. So I think probably your time is also close
Yeah,
to the time, and
yeah.
yeah, so thanks again for the wonderful talk by Xiao-Yang and Keyi, and
Yeah, thanks for
hopefully,
inviting us.
yeah,
We're really enjoying this sharing and discussion.
yeah, thank you. Yeah, hopefully, AI can be more beneficial to finance and also the whole society. Yeah, thank you.
Yeah, let's keep in discussions.
Yeah,
Yeah.
thank you. So see you
Okay.
next time.
Thank
Yeah.
you. Yeah. Good night.
Thank
Bye.
you.